In this demo, we present a novel, reusable tool designed to analyze social interaction in massive multiplayer online games by leveraging Multiparty Conversation Analysis. The design relies on a C# plugin that can be integrated within Unity-based 6DoF multiplayer VR environments with a voice chat. By analyzing in real-time voice and data channels of the game session, it serves as an automatic social feature extractor, oriented both to the individual and social groups. Besides its applicability, we started our journey considering the use case of monitoring social opening signals in online VR social skill training for autistic youth. During a preliminary evaluation with 3 experts of VR group autism treatments, our tool demonstrated its effectiveness in enhancing the power, efficiency, and systematicity of monitoring processes. The design of the tool was driven by adherence to key quality principles. Firstly, it is real-time, ensuring support for potential in-game visualizations. It relies on versatile plugin interface with minimal input requirements while ensuring user privacy is not at risk. Finally, it is designed as a modular extensible structure, leveraging on reusable mechanism for inclusion and synchronization of multimodal data streams. In this diagram, we observe how MCA tool requires access method to retrieve audio channel and the real-time location of each player. These inputs are used to identify groups of players who can hear each other based on voice volume, distance, and spatial audio sources. By integrating the results with a temporal analysis of voice periods of players, we can then segment dialogue, identify the role of participant in them, and extract turn-taking features. Every 2 seconds, snapshot statistics calculated across all layers are transmitted via WebSocket to a web-based report dashboard, accessible during and after the session, which we will explore further in the video. Let's now comment on an internal test conducted by 4 of our collaborators, recorded in first person by the player identified with the magenta color. Not to be confused with the color of the rings placed above each other, corresponding to the unique color of an audibility area. In front of the magenta subject, the orange and green players have already started a dialogue. Their vocal interaction are shown on the voice activation timeline, a widget in the dashboard that provides a summative comparison of each player's vocal contributions. Let's move to the moment when this dialogue ends, and the model delivers its unit. The dialogue unit below is represented by the sequence of turns, each marked by the turn's holder's color, a frame to identifying the color of the conversation, and the individual vocal units displayed above it. Now we move to a more chaotic interaction to describe the mechanism of dialogue creation and extinction. The orange and magenta players are conversating. The dialogue ends when orange moves out of the audibility area. Orange briefly returns in the area but leaves immediately after. This time no exchange occurs, so no dialogue appears on the timeline. Orange tries again entering the area and starting a dialogue. Now the presence of participants becomes unstable. The green players join them, then Orange leaves and re-enters the area. Despite the intermittent presence of Orange, the 3 players contribute to the same dialogue, as there were no more than 4 seconds of silence in the audibility area. Finally, the participant disperse, and the dialogue unit is delivered. Moving swiftly to the end of the session, we notice in passing that the yellow player has also joined, creating several scenarios with 2 simultaneous dialogues. At any point during the session, the user can access the web dashboard to review the accumulated statistics. The available interaction include importing, exporting data, filtering dialogues on which measures will be computed, performing pan and zoom operation on the timeline, and selecting a subject to view individual measurements. We now examine the remaining dashboard widgets. The dialogue size distribution visualizations show the number of dialogues involving a specific number of speakers. These histograms indicate how much each individual contributed to those dialogues. The CA foundational statistic widget details the frequency and the duration of dialogues and speaking turns for the selected player. Dialogue-inducing spatial movements gives insight into the frequency of avatar movements aimed at initiating a dialogue in relation to the selected subject. Finally, we also present the extensive set of measurements that proved to be effective in our user evaluation in monitoring social skill training for autism. This concludes our demo for IEEE 2025 conference. Thank you for watching.